Good morning, students. You are welcome back to our online physics class. Today we'll be looking at the topic magnets. And the major thing we'll be looking at here, we have what is a magnet, what material are magnetic, what is a magnet, and what materials are magnetic. Now to start with, let's look at some of our magnetic material. Ma Magnetic materials are materials that attract magnets. They are material that are attracted by magnets. Example of these materials are iron, nickel, and cobalt. Iron, nickel, these are nickel and cobalt. These are examples of magnetic material. On the other hand, we have non-magnetic materials. And these are the materials that are not attracted by magnets. They are not magnetic. They are not attracted by magnets. Magnets cannot attract them. They can't attract magnets. Example of such materials are wood, paper, stainless steel, silver, and gold. These materials here are not attracted by magnets, so they are called non-magnetic material. Non-magnetic material. And now let's quickly look at the properties of magnets. All magnets have attractive property. In other words, they attract magnetic material. Magnets attract magnetic materials. And don't forget, we talked about, I've given you examples of magnetic material. And again, directive property. That's another property of magnet. That is, a freely suspended magnet always rests in the north and south pole. That's another thing that is peculiar to a magnet. Like you can have it here, you can see the picture of this magnet here. It has both the north and the south pole of the magnet. It has both north and the south pole. Then the geographical north is called north pole, while the geographical south is called the south pole. These are terms under directive property of magnets. Now, looking at the bar magnet, that's talking about the property of magnet again. This is a bar magnet. We have the red part here, we have the blue part here. Here we have the red part, we have the blue part, which denotes both north and the south. North and the south. Now, if you have a magnet, you break this magnet into smaller pieces. No matter how small the pieces is, it will always have both north and south. Break it into several parts. Pole of magnets cannot exist independently. Now, looking at the two magnets here, if you bring them in contact, north to north or south to south, there is always what we call repulsion. They repel each other. In other words, if we have a north pole here, we have another north pole here. Sorry, this is not north, but if we have both sides here and this side north, they will always repel each other. And if they are south, they do what? Repel each other. That's another thing that is peculiar to all magnets. Then, if we have north to north, north to south, or north to south or south to north, whichever way, there's always attraction. In case you have unlike poles, here for example you have north and here you have south. North and south, They are not like poles. They are unlike poles. There will always be an attraction. Attraction. Then take note of these important points. The attractive property of the magnet is maximum at both at both the pole and decrease towards the center. What we are trying to say here is that if we have a magnet, the attractive properties is maximum. The strength of the maximum lies at the edge of the magnet. In other words, at the edge of the magnet, let's say this is the north, is stronger there, and the south is stronger at the tip of the magnet. That is what that point is trying to let us know. Now, looking at magnetic compass, we must have come across this magnetic compass in one way or the other. A magnetic compass is a simple device that gives the directive property of the magnet. It gives what? Directive property of the magnet. It consists of a small flat magnetic needle, like we can see here. The knots of the needle marked with red. Why with red color? You can see the knots marked with red color here. That's the north side of the needle. It's marked with red. Directions such as north and northeast, east, southeast, south are marked at the base. You can see it here. You can see the north. You have the north here. You have the northeast, east, southeast, south, southwest, west, northwest, then coming back to the north. Then again, the magnetic needle is free to rotate about its center and point in the north-south direction. That is, the magnetic needle is free to rotate about the center, like we have seen here. That's the magnetic needle that we're talking about, that having the red and the white. It's and point in the north-south direction. Then coming back to another subtopic here, we have magnetic field. Magnetic field. The region around the magnet where magnetic force exists is called the magnetic field. In other words, where the magnetic force is experienced. Magnetic field is the region surrounding the magnet where the magnetic force is felt, or where the magnetic force is experienced. A field, like as we know, is represented using field curve line called magnetic line of force. That's talking about magnet. Is represented using field curve lines called magnetic line of force. Please take note, very, very important. It originates from north to south. And please, while drawing this, you must always put the direction. It originates from north to south. This point is very, very important. Then that's the direction. You can see you have the north here, you have the south here. Can we see the arrow? Originate from north to south. Originate from north to south. You can see the arrow moving towards the south. That's talking about the magnetic line of force. Let's move on. You have the magnetic field line of force are continued curve. It starts from the North Pole and end at South Pole outside. Their direction is north to South Pole. However, inside the magnet, the direction is from south to North Pole. No two lines of a force ever intersect with each other. Like you can see there, you can see no two lines of this line of force intersect. They are not crossing each other. Please take note of that in case you are asked to draw. Then densely populated line of force indicates a strong magnetic field, whereas widely distributed line of lines indicate a weak magnetic field. In other words, at the tip here we have a very strong magnetic field. At the tip here we have strong magnetic field. Meanwhile, at the middle we have weak magnetic field. This is due to the line of force that is densely populated at the edge, both north and south.